you already know about for, repeat, while and forever loop from last episode. There is another special kind of loop exists in Verilog and specific to digital design. This is none other than generate loop. In today's episode, we will go through its definition and thorough examples. Stay tuned till the end of the video. Hey guys, welcome back. In today's episode, we are going to discuss the below points. First, we'll do an introduction and we'll talk about what is a generate block. Next, we will show an structural example how the generate block looks like. Next, we will talk about the local param and the Genver reference, which are very much specific to the generate block. Next, we will talk about the DefParam and its use in generate loop. Next, we will talk about implicit array in generate blocks. Next, we'll talk about generate blocks, hierarchy and error. Next, we'll start our section for different examples like legal or illegal coding and parameterized continuous assignments in generate block. Also, we'll see the example of generated ripple adder and multi-level generate loop example. This way, we'll cover all the points in our today's episode. Without any further delay, let's begin. Introduction. Generate constructs are used either conditionally or multiply instance generate blocks. So these are the two ways that a generate block constructs are used. Next, a generate block is a collection of one or more module items. A generate block may not contain code declaration, parameter declaration, specify blocks, or spec param declarations. I think the specify and the spec param, these two have not discussed yet in this series. We will later discuss in some other episode. But for now, you know that all these things may not be contained in a generate block. Next, all other module items are allowed in a generate block. So apart from these modules, right, these things, we can use any other module or related stuffs that we have came across so far. Next, the elaboration of generate construct results in 0 or more instances in a generate block. So the elaboration step happens when the simulation tool is run. So it is one of the sub-steps. So during that particular sub-step, a generate construct results in the expansion in either 0 or more instances in the generate block. So this is somehow similar to the concept of flattening. That means we have a description which get flattened during the elaboration, and the generate blocks get flattened during the elaboration. The keyword pair generate and nGenerate may be used in a module to define generate region. So these two keywords may encapsulate the things that should be contained in a generate block. So that's our introduction for the generate block. We're done here with the slide. Let's move on to the next slide. How the generate block looks like. Here we'll have a structural example. Here goes the structural example. The generate block looks like we have a generate keyword, then followed by for loops, if-else statements, case statements, and instantiation statements. Instantiation means we have different predefined modules or the existing modules which came in the library, right? All the instantiation statements. And then finally, we use the nGenerate keyword to encapsulate the entire generate block. So the generate block starts here and ends here, and in between it may contain all of these things. This is the structural example of the generate block. We are done with this particular slide. Now let's deep dive inside the generate block concept. What is generate block? Now we will have a much more in-depth view of the generate block apart from the introduction we have just came across. So let's start. A loop generate construct permits a generate block to be instantiated multiple times using the syntax nearly similar to a for loop statement. So once after a couple of slides of description, once we go for the examples, you will see and you will able to relate this comment. The looping variable shall be declared in a Genver declaration. So this Genver is a special variable and this is a specific keyword has to be used for the generate block, and that particular looping variable means like a for loop we have a looping counter and generally we use I equal to something like. So that I here has to be defined by the Genver declaration prior to its use. So remember we have to declare the Genver prior to its use. The Genver is used as an integer during the elaboration stage. So it gets flattened during the elaboration stage of the simulator. It evaluates the generate loop and create instances of the generate block. It vanishes way before the transient digital simulation start. A Genver is limited to use in nowhere other than the loop generate construct only. Both the initialization and iteration must be done using the same Genver. So here we are done with the in-depth question of what is generate block. Now we will have some additional information about this generate block in the next slide. So let's move on to the next slide. Local Param and Genver reference. Let us see what these things are and why they are important. An implicit local param declaration automatically happen within the generate block of a loop generate construct. So this happens automatically, a local param declaration. This is an integer parameter that has the same name and type of the loop index variable. So loop index variable which is defined by the Genver. We have just talked last slide. Its scope remains up to the generate block decided at the time of the elaboration process step. So this scope remains within the generate block. So it do not go out of the generate block. That means this integer parameter. In the examples you will come across all these things. Now we are going through the theories. This parameter can be used anywhere within the entire generate block as a regular integer parameter. Remember, this is an integer, right? And in digital electronics, it is not a voltage or something, it is an integer. So this is the identity of this parameter. It can be referenced with a hierarchical name. So we will see in the examples how the hierarchical name will come out. Because this implicit local param has the same name as the Genver, any reference to this name inside the loop generate block will be reference to the local param. This is another kind of mapping we have, and it will not be reference to the Genver. Hence, it is not possible to have two nested loop generate constructs that use the same Genver. So this is very, very important. So we cannot have two nested loops with the same Genver. So this is the reason, because it will create reference and that will refer to the local param. Now we are done talking about the local param and the Genver reference in this slide. So let's move on to the next slide. DefParam and Generate Loop. Now we will talk about what a DefParam is and how it is significant to a generate loop. First here, we talk about some points. First, using the DefParam statement, parameter values can be changed in any module instance throughout the design using the hierarchical name of the parameter. So this is the basic definition of a DefParam. However, a DefParam statement in a hierarchy in or under a generate block instance or an array of instances shall not change a parameter value outside the hierarchy. So this is very much specific to the generate block, how a DefParam should behave in a generate block. Next, each instantiation of the generate block is considered to be a separate hierarchy scope. These all things will come out in the elaboration step and it has to be remembered. Now let us see a short and sweet example here. We have Genver I, we have generate, and here we have I equal to 0, I less than 8 and I equal to I plus plus. So this is the counter, for loop counter, and we have a begin, and here we have given a name, that is some name. This is just a name for this particular for loop. Now we have our flop instantiation here. Next we have the DefParam statement, and this way we have written the DefParam, and we end our for loop here. And finally we end our end generate. So this is generate and end generate block. So this way the DefParam, that means this DefParam can be used inside the generate block. So this is just an example. When we are going through thorough example, you will be able to see its use. So here we are done with this particular slide. So let's move on to the next slide. Implicit array in generate blocks. This is another significant concept that you must know before you use the generate block in hand. Generate block in loop generate constructs can be named or unnamed. Generate block that consist only one item don't need the begin or end keyword. So this is another freedom. If it contains only one item, the begin and end keywords can be omitted. If generate block is named, an implicit array created consisting of the generate block instances. So for a named generate block, right, implicit array is created. The index values of this array are the Genver values during the elaboration. So everything happens during the elaboration. This can be a sparse array because the Genver values do not have to be in the form of a contiguous range of integers. You understand the contiguous means, right? One after another. Here, this can be a sparse array where things are not contiguous. The array is considered even when there are no instances of the generate block. So this is another good and important point to be remembered. Now we have talked about the implicit array and generate blocks. Now let's move on to the next slide. Generate blocks, hierarchy and error. We will see about the hierarchy and errors that we may face. If the generate block is not named, the declaration within it cannot be referenced using the hierarchical names other than form within hierarchy instantiated by the generate block itself. It shall be an error if the name of a generate block instance array conflicts with any other declaration, including the other generate block instance array. Next, it shall be an error if the loop generate scheme does not terminate. It shall be an error if a Genver value is repeated during the evaluation of the loop generate scheme. It shall be an error if any bit of the Genver is set to X or Z during the evaluation of the loop generate scheme. So these are good points. You have to be very careful and remember them. We're done with this particular slide. So let's move on to the next slide. Examples. Here in this slide and the next slide, we will give some examples which are legal and illegal. That means you may face error or you are okay. So let us see the example and case by case we will talk about. First one, here we have a module, mod A, and we have Genver declaration. This is I, and then we are omitting these things, right? Or generate and in-generate keywords are not required here. In this example, we have not used it. We have a for loop with the Genver, and here the counter runs with the Genver, and we have the name A. We have the same Genver here in the counter of the next for loop, and the name is B. So you can see this is kind of a nested, right? And we have the statements and etc. here. And here you will face an error because we are using I as a loop index for two nested generate loops, and here we are using the same Genver here, and this I used in both of the counters of the nested, and this gives an error in the Verilog code, and we complete our code here. So this you cannot do, right? So you have to keep in mind. That means this is a illegal one. Let's go to the next example. We have a next module mod B, and here we have Genver I, and we have range A. We have a for loop begin, and we have given the name A. We have the statements, and then we face an error, right? Why? The error is for the A conflicts with the name of the range A. So here it is A and here it is A. So that's why it will face the errors. And here we end it, and the module is ended. So here in this slide, we have seen two different errors, which are the illegal use of the Genver. So you know what not to do right now. Let's move on to the next slide where we will see the similar category of an example. We have module C, and we have again Genver, and we have a for loop, right, where we have the counter here with the Genver, and its name is A. Or we have all the statements, and we have the end for this particular for loop. Next we have another for loop where we have another counter where you can see this is different, and the checking counter is also different, and here we give a name A, and we have the internal statements of the for loop. Then we here face an error because here A conflicts with the name of the previous loop even though the indices are unique. So here you can see here this have a clash with these because these two for loops are different, and here we put the end and end module. So now you know that the two different for loops which are not in a nested format but have the same name, it may have a clash. This is illegal. You know what not to code with the Genver. Here we are done with this particular slide. So let's move on to the next slide. Parameterized continuous assignment example. So here we start our example. We have the module gray to binary 1, and this is binary and gray. We have parameter size, its size is 8. This module is parameterizable. Output is size -1 down to 0, and this is bin, right? This one is the output, and input is size -1 down to 0 is gray. This is the input. We also have the Genver here, and we start our generate block with the generate keyword, Next, we have the for loop, and here the counters are there and its name is bit. We have an assign statement here, and we are using this equation for the assign. And here I refers to the implicitly defined local param whose value in each instance of the generate block is the value of the Genver when it is elaborated. So this is the way here we are using the I, and also we are using the local param here. So let me read out again in a continuous mode. I refers to the implicitly defined local param whose value is in each instance of the generate block is the value of the Genver when it is elaborated. And here we close our generate block with the end generate command, and we end our module. So here in this example you have seen how a parameterized module can be fitted with the generate block. We are done here with the example. Let's move on to the next slide. Generated ripple adder example. Here we go with our code. Here we have the module adder gen, and we have the all PO, sum, A, B, C, I. So this is carry out, this is carry in, and this is A, B, this is sum. So here we have the parameter size 4. We have the output size -1 down to 0 sum, and we have output CO. We have input size -1 down to 0 AB, and we have input CI, and also we have where size down to 0 C. Here our definition has ended and our Genver is declared here. Genver is I, and we assign CO equal to CI, and here is our for loop using the Genver. That means here our generate action is started and the name is bit. Here we have the statements going inside. First we have the where statement, then we have the XOR instance, and we have the another XOR instance, and we have the AND instance. So these are primitive gates, right? And we have the AND instance here, and we have the OR instance here. So this is a kind of structural modeling happening here. You can see the entire block here is the structural modeling. And here we end our for loop. So in the episode of structural modeling, I have talked in detail how the structural modeling happens with the explicit diagrams. In case you have not watched that episode, please go ahead and watch it from the playlist. Here we have the assign CO C size, and here we have the end module. Here the code is done. Now let me give the things that come in the elaboration, right? Here the hierarchical gate instance names will come in the elaboration, like XOR gates will be like this, and this is another XOR gate. Also we will have AND gates with this kind of hierarchical name, and this is another AND gate. We have also the OR gates, and this kind of hierarchical names will come. And the gate instances are connected with the net named. This is the net name, right? And this is another hierarchical name, So here we are done with the code example, and we have seen how the elaboration helps to get the hierarchical instances of the gates as well as the nets. So this way the generate block gives birth to the hierarchies during the elaboration. We are done with this particular slide. Let's move on to the next slide. Multi-level generate loop example. Here we start our code, and here the parameter size is 2. Here we have multiple Genvers I, J, K, M, and we start our generate block with the generate keyword, and we have first for loop, and its name is B1, and next we have its statements, right? Next we have the next for loop which has B2, and here we have the instantiates this one, right? First on instantiate this one, and here is the third for loop, and this is, so these are nested, right? So you can see the things are proceeding down and down, right? Here first I, J, and then K. Here it was I only, here it is I and J. So this way you can see the hierarchies go down. Now we have here instantiates this one, right? I, J, K, and then N3. Next we have an end, and then we have the if, right? This is B4. If block has the name B4. This is scope is that B1.B4. Here we have another for loop whose name is B5, and it gives birth to the scope of this, right? B1I, B4, then B5, and then M. Then we have the instances here with this hierarchy, and then we have end, and generate. You can see in the code this multi-level. That means we have a multi-level, multiple nested loops are there. And here we have used different Genvers for the different hierarchies. The first hierarchy is with I, second one with J, third one with K, right? And here the fourth one is with M. So here you can see that we have used the proper legit code for the hierarchies using the Genvers and how the things go inside and how these things are expanded. So here we are done with our particular example in this particular slide. So let's move on to the next slide. Thank you very much for watching up to this point, and don't forget to like, share and subscribe. In case you have some dislikes, put that as in comments in the comment section down below, and bye for today.